Have you ever wondered how big AI models like Claude, ChatGPT, and Gemini got so smart? I have, and that's why I jumped at the chance to learn more from Anthropic engineer Hansohl Kim. Hansohl, what exactly is reinforcement learning, and why does it matter?
When people tend to think of AI these days, they hear the word machine learning, neural network, deep learning, LLM, and these terms all sort of start to blend together. But the reality, of course, is that AI is a field of study that's been around for actually, several decades at this point. And it has a lot of different sort of subfields that have gone in and out of popularity and style over time. RL is one of these, reinforcement learning. And it wasn't originally obvious how this related to deep learning or neural networks, especially back when I was first studying this topic in 2014, 2015. But the key difference between reinforcement learning and what we typically think about, supervised learning, is in supervised learning, you're in this world of data sets and ground truth labels. You tend to think of having an AI system where you put a lot of data in, and for everything that goes in, you have a real sort of ground truth answer for what you expect to come out. Then the model gives you an output and you compare it to the ground truth and you correct the model. You say like, oh, you output the number 5, the ground truth was the number 6. Let's push everything, all of your weights towards making that 5 a 6. This is extremely powerful and it got us largely to where we are today in terms of AI technology, but it has a lot of drawbacks as well. For example, actually being able to acquire all of that labeled data can be really difficult and prohibitively expensive. Likewise, supervised learning where you have this sort of like real ground truth answer that you're comparing is actually fairly brittle and rigid. And in this sense, you can apply this well to situations where there is a clear answer, where there is a clear ground truth. But let's say, for example, you wanted to ask an AI model to make music. There's not really a clear ground truth or correct answer to that. And so trying to train a model to learn a task like that starts to break down. This gets even worse if you say, create beautiful music, because at that point, the problem is really undefined and who is even really qualified to be creating the ground truth for that? And so at that point, when we started hitting these problems that are really quite difficult to frame as here's the correct answer, we reached back in time to a different field of AI called reinforcement learning, where the idea is a subtle difference. You don't tell the model, here's the correct answer and how to do it. You just tell the model, I think your answer is good, or I think your answer is not so good. And instead of providing the exact comparison, you just provide a general signal of, nah, that's, I judge that to be a 5, or I judge that to be a 10 out of 10. And the difference actually starts to become quite powerful in that there is this sort of flip that happens where once you, as the sort of teacher of a system, no longer have to produce a real example of the answer, in some senses, you can start to teach things that you yourself don't know how to answer, because you don't actually have to provide the real answer. You don't have to know how to make an answer. You just have to know how to judge or gauge whether the answer is better or worse. And this becomes especially meaningful today when we talk about ideas like alignment. Alignment is this sort of task of taking extremely powerful AI models and trying to ensure that they have behavior that is aligned with what we value or what we're concerned about. In a very sort of broad sense, we might say morals, perhaps, but of course that's can be a fairly vague term to many people. So we prefer to say the model is aligned. And again, that's an example of a very vague problem where you can't necessarily say, here's like a ground truth example of a hyper powerful AI system that we believe is behaving well. Instead, you can create systems where you say, oh, please output your responses to this, and we will give you feedback signals, not necessarily the right answer because no one knows that, but feedback signals as to whether you are doing something that is helpful, something that is harmful, something that is honest, something that is manipulative. And yeah, this is about where reinforcement learning has landed in modern AI.
So how do you put these ideas into practice at Anthropic? Is it all reinforcement learning, or are there other kinds of training that also play a role?
Yeah, so one way I like to think about how reinforcement learning plays out for modern large language models is to say that we're more familiar with this idea of supervised learning, with this idea of massive data sets, and the role that plays in an LLM's life. At the beginning, you pre-train a model on a massive amount of text data. And in this case, the way the ground truth is being applied is the model receives some text as input and then tries to produce whatever the next word would be. And in that case, it is actually framed as a problem of here's the correct output. That is what I would describe as the starting point for a, quote, intelligent system these days. This used to be the endpoint. I think of the supervised learning portion, the pre-training portion, as sort of like a human baby or child that has the sort of biological brain to have already been capable of processing information, analyzing information, thinking, even when they're basically fairly young, just after being born. And the pre-training process, as all of the evolution that has gone up to building that biological brain that is capable of thinking and putting together ideas. Conversely, the reinforcement learning section is really a lot more like that child growing up and learning how to use that brain and how other people are teaching them to use that brain. Yes, the pre-training is incredibly important. It teaches the models to get to a point where they can actually analyze information. An incredible discovery that we found, at least apparently, is that if you do this enough, it actually generalizes to being able to generally put ideas together and process information and find patterns. But then when you say, what do I actually want my frontier model to act like? How do I want it to behave? In fact, there is an entire sort of effort of people who are effectively trying to give Claude a personality of Claude. What does that mean for Anthropic's model? Those stages are all really reinforcement learning. And in my day-to-day, that means that when the model is capable of thinking, a lot of what we then work on is, okay, how do we teach it how we want it to act, behave, and in some cases learn additional, more complex meta skills like strategy, planning. In the engineering field, typically what this means is a lot of very complicated, massive scale work, understanding how large, complicated systems behave at scale, because reinforcement learning requires an incredible amount of complexity in being able to have a model that is interacting with the world and producing ideas and producing answers. And then you need an entire system that's then going to gauge those answers and give that feedback. And then you need to then shuttle that back and have the model update itself based on how it's interacting. And in a lot of ways, this is actually a more natural model for us as humans of how we learn and think. But it does involve a lot of very finicky engineering handling systems, very distributed systems at very large scale.
Click this video to hear more about how AI works under the hood.